This video tutorial will cover some basic geometric exercises and introduce us to some simple proofs that we can do with our students. So we'll be using a ruler, a sharp pencil, our set square, and probably an eraser. So let's begin. Let's begin with looking how to draw parallel lines using a ruler and a set square. So we'll begin with a line. So this is line A, B. And now we want to draw a parallel line at the height of point C. So what we do is we place our set square along the given line AB. We line up our ruler so that we're creating a right angle. And then, once everything is all squared up, we simply slide our set square to point C and draw a line. So now we can say that these two lines are parallel. Okay? If this was line D and E, we could say that line AB is parallel to line DE. So that is one way to create parallel lines. Now we can also create parallel lines using our compass. It's a little bit more complicated, but I might as well show you. So let's begin with a line. Again, let's say we'll call it line AB. And we want to draw a parallel line at point C. So at this distance away from line AB. So the first thing that we will do is we can create a point down here, and we'll call this point D. So let's draw a line from C to D. And this is just a line which will be a guide. Okay. Now, with our compass, we are going to copy the angle at D. In other words, we are going to copy this angle at point C. So we can take our compass, place it on point D, and sweep an arc that touches both line AB and the line we have just drawn. And now we are going to copy that arc by placing it at point C. And we sweep an arc. Now we are going to copy the angle at D by setting the compass equal to the distance where the arc touches the two lines. So it's always easier to show. I'm going to place the compass here and set the compass equal to this distance right there. And I'm going to transfer that to where I drew my last arc, and I'm going to sweep an arc so that it crosses the previously drawn arc. And now, if I line up point C with where the two arcs intersect, always remember to measure I now have another set of parallel lines. Let's move along now. Oh, before we do that, let's just go back and just explore here. If I was to draw a line that crosses these two parallel lines in this kind of a way, I could see that, for example, the angle at C is the same as this angle here. So these are corresponding angles. All right, now let's move to another exercise. And let's take two non-parallel lines and have them cross together. So let's take two non-parallel lines and have them cross together. Now the question is, does this angle equal this angle? So this leads us to our first proof. And we're going to start this proof with these two crossed lines. And remember, before we do that, there is a piece of information that we need to know and recognize. And maybe I'll just put it over here. And that is that a straight angle is equal to 180 degrees. A straight angle is equal to 180 degrees. So now we go back to this, and we're going to try to prove and ask the students, how can we prove without using, some measuring device, that these two angles are in fact the same? Well, let's color the angle in between them. So let's see here. We have two orange angles and one green angle between them. How does that help us with our proof? Well, eventually, through some leading questions, we can come to the place that, isn't it so that the orange angle on the right and the green angle equals a straight line? Yes. that is so. Isn't it so that the orange angle on the left and the green angle equal a straight angle? Yes, that is also true. So these equal 180 degrees, and these equal 180 degrees. Then, if two things and a third are equal to something, then the two things must be equal to each other. And therefore, the orange angle on the left must be equal to the orange angle on the right. It's a very qualitative, logical way of proving this fact. Now, next exercise. Let us take two parallel lines. By the way, these are opposite angles. Okay. And we're going to draw a line that crosses these. And we're going to call this angle A, angle B, and angle C. Now, can you see that angle A and angle B are equal? So we have angle A equals angle B. We can see that angle A is equal to angle C. We know that from this previous proof. So angle A is equal to angle C. Therefore, angle C must be equal to angle B. And we call these alternate angles. Angle C must be equal to angle B, usually in this zigzag pattern. All right, now let's build on this and move to another proof. We'll begin by drawing a triangle. And it can be any kind of triangle. Now this leads us, what we've done so far, it leads us to a proof, or to proving that the interior angles of a triangle add up to 180 degrees. Trying to prove that these angles here, the sum of these angles, add up to 180 degrees. It's not just good enough to read that or to be told that, but let's actually prove it. So let us, for clarity, just extend the base of this triangle. There's a couple ways of proving this. Next, we're going to draw a parallel line above the triangle that touches the apex of this triangle. So we line up our set square, get all squared up, slide it up, and there we are. Let's, we know that these lines are parallel with each other. Let's label these angles. Actually, let's color them in first. So let's have this angle up here be dark brown, or is this black maybe? And let's let this angle be green. And we'll let this one be orange. Okay, and let's label these afterwards. So we know that this angle here has to be equal to this angle. These are alternating angles. So let's make that green because it is equal. And similarly, we know that this angle has to be the same as this angle. Now let us label these angles. So we'll call this angle A is equal to angle B. We can say that angle C is equal to angle D. And that leaves us with angle E. So we know that here's what we know. We know that angle A is equal to angle B. We also know that angle C is equal to angle D. Now this third angle, do you now see the proof when we look at the third angle? Well, let's write it out then. If angle D, E, and B, if angle D, E, and B equal a straight angle, 180 degrees, then similarly, the green angle, the orange angle, and the dark brown angle here must also equal 180 degrees. So let's just write that out. If angle D, angle E, and angle B equal 180 degrees, which by the way is called a straight angle, then angle C or ACE, then angle A angle C and angle E equal 180 degrees. So therefore, we can say the interior angles of any triangle add up to 180 degrees. Now there's another way of looking at this kind of proof. It's similarly elegant, and let's begin, but it's a little bit more tactile. So we can start with any angle or any triangle. We color code it, in this case green, angle orange, and the black angle. Now we know that if we take these angles, we know that if we were to add them together, they add up to a straight angle. So we can do that quite literally by cutting the angles off and placing them in a certain way. And now we can see that the sum of these angles is a straight angle. So this is another way to prove the same theorem, and that is that the sum of the interior angles of a triangle add up to 180 degrees. Students can try this with any kind of triangle. It doesn't have to be an equilateral triangle or a right angle triangle. They can try it with a scalene as well, and it always adds up to a straight angle. Thank you for listening.